I just deployed the token of Eat the Blocks, and I will show you the whole deployment process step by step. This is a real-life deployment to the mainnet of Binance Smart Chain. No testnet this time, mainnet like big boys. And if you are new here, I'm Julian, and on Eat the Blocks I teach blockchain development. Before we jump in the deployment, I want to explain briefly why I'm launching a token for Eat the Blocks. One of the main problems on the channel is how to find the best topic ideas. So far, the process has been pretty organic. I collect feedback from emails I receive, YouTube comments, and it helps me to have ideas for content. But I wanted to make the process better. So I asked the community of Eat the Blocks in the poll how we should vote for the content of Eat the Blocks in the future. There were several options, and the option that won was to vote with a dApp and a token. That's why we are doing a token. Another question in the poll was on which blockchain to deploy the token. There were several options like on Ethereum L1, on Ethereum L2 chain, or on Binance Smart Chain. People voted for Binance Smart Chain, so we are going to deploy the token there. Besides the low gas fees, another advantage of Binance Smart Chain is that it's based on the EVM, which means we can reuse all the development tools of Ethereum. So I'm going to show you the Solidity code of the token. So this is in the GitHub repo of Eat the Blocks. This is a standard truffle project, and we are using Solidity 0.8.3. which is the latest version of Solidity at the time of recording this video. So the smart contract is in the contracts folder. This is ETB token. And this is a very simple smart contract. We first declare the pragma statement for our version of Solidity. Then we import ERC20 from OpenZeppelin. If you never heard of OpenZeppelin, this is a Solidity library that has some standard implementation for tokens like ERC20. It's generally a bad idea to do your own implementation for a token. It's better to take the template of OpenZeppelin, and that's what we are doing. There are several versions of OpenZeppelin, and I install version 4, which is compatible with Solidity 0.8. And after below, I define the token, and I make it inherit from ERC20 from OpenZeppelin. And just with this line of code, we inherit all the functionality of the ERC20 implementation of OpenZeppelin. It's very easy. And after that, all we have to do is to define a constructor where we call the constructor of the ERC20 of OpenZeppelin. And then we pass as argument the name of the token and the ticker. And in the body of the constructor, we're gonna mint some token by using _mint. So this is provided by ERC20 of OpenZeppelin. And the first argument is the recipient of the token. So that's the address that deployed the smart contract. And after the amount of token, so this is gonna be 1 million times 10 power 18. So that means that we're gonna have 18 decimals in our token, like most of the existing ERC20 tokens. If you never heard of decimals, this is to deal with a fraction of a token, and this is using the same standard as for Ether. So when you transfer 1 Ether, you actually transfer 10 power 18 elementary unit of Ether that we call Wei, and for token, we usually use the same convention. And after that, I'm going to show you the test. Token.js. We don't need to test the basic functionality of ERC20 like transfers, because these tests are already written by OpenZeppelin, but we're just going to focus on what is specific to our token, which is the initial allocation of 1 million token to the deployer of the token. So here we define a contract block, we define a couple of variables, a variable for the token, we extract the address of the admin. So this account array is provided by Truffle. Then we define a constant which represents the total supply of token. So this is 1 million times 10 power 18. And before each test, we are going to deploy a new token. And after, we have a single test here. So once the token is deployed, we're gonna read the total supply as well as the balance of token of the admin. So these two functions, total supply and balance of, even though I didn't define them myself in the token, they are still available because they are in the ERC20 implementation of OpenZeppelin that we inherited from. And after, we're gonna run 2 assertions to make sure that the total supply and the balance of the admin are equal to the total supply constant. So I run this test on my computer, it passes, so we are good with the code of the token. So in this section, we are going to deploy the token to the mainnet of Binance Smart Chain. And to do this deployment, I'm going to sign a transaction with a hardware wallet. So we're going to need to find a way to integrate this hardware wallet with Truffle. But fortunately, there is a Node.js package for that. So in package.json, I installed Truffle Ledger Provider to integrate with a Nano Ledger. And I also installed Babel Polyfill. It's to fix a bug. I'm going to explain just after. So let's go back, and after in Truffle config. So here the important part is we need to import this Ledger wallet provider. And we also need to require Babel Polyfills. And we do this to fix a bug in Truffle Ledger Provider. I'm not going to give you more detail, but I just did a quick Google search when I had a bug first, and I did this and it fixed the bug. And after, let's see the configuration necessary. So we go in networks. And so I define a network for the mainnet of Binance Smart Chain. And here for the provider, we use Ledger Wallet Provider, and we pass it some options. So network ID 56, this is the mainnet of Binance Smart Chain. Account offset 0, that means that we want the first address that is managed by the Nano Ledger. Then we specify the URL to Binance Smart Chain. So this is a public node that is operated by the team of Binance. And after, we specify the gas limit. So in order to get this parameter, I first deploy the token on a local development blockchain with the Truffle develop command. And I saw that the deployment cost was this, so this is going to be our gas limit. As for the gas price, so I went to BS Scan, which is basically like Etherscan but for Binance Smart Chain, and I checked the latest transactions, and I saw that they were using 5 GUI for the gas price. So I took the same thing, so 5 times 10 power 9, because 1 GUI equal 10 power 9, then network ID 56. And you noticed here that at no point we specified the mnemonic or the private key in Truffle config. The private key is stored safely in the hardware wallet. Alright, so let's go back one level. And after, I created a migration file. So very simple. We just import the token and we deploy it here. Next, I send some BNB token to the deployment address. This is going to be necessary to pay for the transaction fee of the deployment. And after I connected my hardware wallet, I unlocked it, and I run this command in my terminal to initiate the deployment. So first, it deploys the migration smart contract of Truffle. This is a contract that is used internally by the Truffle framework for the deployment process. So on my Nano Ledger, I saw a first transaction to confirm, so I accepted it. So it launched the first deployment. Then there was another transaction. So that's some data that is saved on the migration contract. This is also something internal to Truffle, so I also accepted the transaction. Then the third transaction was the actual deployment of the token. So I also had to accept this on my Nano Ledger. And finally, there was a last transaction that was to do an update on the migration smart contract of Truffle. I also accepted this. So total, there were 4 transactions for this deployment. And after that, the deployment was complete, and you can see the address of the token here. So the whole deployment process is supposed to be safe. However, there is still a little risk. It's possible for a hacker to create a wrong transaction that basically steal all your money and send this transaction to your hardware wallet. And if you're not careful what you confirm, you can basically accept a transaction that steals all your money. And that's what happened to the CEO of Nexus Mutual a couple of months ago. That was stolen $8 million like this. And here the critical part is the Truffle plugin that connects to the Nano Ledger. So this is published on NPM, and if unfortunately it gets hacked, it's possible that hacker managed to steal your money. So first I checked the release date of this package on NPM. I saw that it was published 7 months ago. So if there was anything suspicious in it, probably that by now would have heard something. So I felt a little bit safer because of this. And another thing I did to protect myself is that when I had to accept the transaction on my Nano Ledger, I made sure to check that there was no BNB token that was sent in a transaction. And I also made sure to check that the to field look correct. So when you create a new smart contract, the to field is going to be empty. So normally with Nano Ledger, you're very safe, but it doesn't hurt to be extra cautious. Because if the CEO of Nexus Mutual was stolen $8 million with a Nano Ledger, so can you. And we can check on BScan that the transaction actually took place. So this is the address that deployed the token. So we can scroll down a little bit. So first of all, we can notice that there is a little bit less BNB compared to before the deployment. So there was about $53 of BNB before, now we have 47. So total it cost us $6, which isn't too bad considering that on Ethereum, nowadays with really high gas price, it can easily cost you 50, 100 bucks or more if you want to deploy a smart contract. And after we can scroll down and here we can see the 4 transactions of our deployment. And the one that matters is the third one here. This is a contract creation. This is when we deploy the token. So let's click on this. And here we can see that this is the same address that we saw before in our terminal. This is the address of the token. And at the same time here, we can see the initial minting of 1 million token that were sent to the creator of the smart contract. So let's inspect the token of the blocks. So this is the address. And here we can already see that he recognized that this is an ERC20 token. So we can see the symbol, ETB, and the name blocks token. So in terms of security, our private key never leave the hardware wallet. After you deploy a smart contract to mainnet, it's very important to verify it. When you verify a smart contract, it means you prove that the code you deployed at the stolen address is really the code you claim it to be. Otherwise, you could create a bogus smart contract that steals people money. Then you deploy this contract, then people send money to this contract thinking it's a good contract, but your contract actually steals everything. The way verification works is that you upload the source code to the contract to the website of BScan. Then BScan will compile your contract to EVM bytecode. Then BScan will compare the EVM bytecode of the compilation to the EVM bytecode that is stored in the blockchain of Binance Smart Chain. If these two matches, it means that the deployed smart contract is really the code you claim it to be. In this case, BScan will show a verified mention on the page of your contract, which makes your contract more trustworthy for users. Just to be clear, for this system to work, it does require BScan to be a honest actor. BScan is a trusted website in the blockchain community, so it should be fine. It's possible to do the verification manually with the interface of BScan, but it can be a bit tricky because you need to provide the whole source code in a single file, which is not always easy because we often use import statements like for the token of the blocks. And another caveat is the options you use for compilation. If you don't configure exactly the same compilation option for the verification process, it's going to fail. That's why it's easier to use the Truffle Verify plugin. This plugin directly reads the compilation options in your Truffle config and connect to BScan using the API to trigger the verification process. Note that for this plugin to work well, you need to also have used Truffle for deploying your contract. Okay, so let's see how we can configure this plugin in our Truffle project. So first, the package we need to install is Truffle plugin verify. Then in Truffle config, you're going to scroll down, and at the very bottom below the compilers option, we're going to add these configuration plugins and also API keys. And here you will need an API key for BScan. So for this, you go to the website of BScan, you go to sign in, you create an account there, and after in your dashboard, you'll be able to create an API key. So you copy paste it in your Truffle config, And after, we're going to run a command of the verify plugin. So let me copy paste this. So in the terminal at the root of your project. So for our contract, it's going to be ETB token, and the network is Binance Smart Chain. Okay, let's run this. And it successfully verified our contract. So we're gonna check this on Binance Smart Chain. So let's load this URL. So this is the address of the token. This is correct. Here you can see the correct info, the blocks token, ETB. And here we can see the green check mark, contract source code verify, exact match. Everything worked well. And here we can see the contract source code, and we can also read the contract here. So for example, let's get the balance of my address. Query, and we can see this is 1 million token. Number of decimal, this is 18. Name is the blocks token. Symbol ETB. Total supply 1 million token. So everything is fine. The next step is to distribute these tokens to the community of Eat the Blocks, and for this we will do an airdrop, which means everybody can get these tokens for free. With these tokens, you will be able to vote for the content of Eat the Blocks on YouTube. And later, we will add some other capabilities to these tokens. To participate in the airdrop is totally free, you just need to register, and I put the link in the description just below. Enjoy the free tokens, and I will see you in another video.